Hello my dear students, and welcome to another video for our class in Programming 2. In this video, we are going to talk about recursion in programming. So what is recursion? The process in which a function calls itself directly or indirectly is called recursion. And the corresponding function, invocation, is called the recursive call. Using recursive functions or recursive algorithm, certain problems can be solved quite easily. So every time you see a function that contains an invocation of itself, that is a recursive function. Or you could say that is a case of recursion. Recursion is a way of solving problems via the smaller versions of the same problem. We solve the problem by the smaller sub-problems until we reach the trivial version of that problem. So when a problem requires that the same action shall be done on the smaller pieces of the input or data until a certain state such that the action can no longer be performed, that is when it is best to use recursion. There's a very important rule when doing recursion, which is very similar to the rule of using the while loop. A recursive function must have an end condition which determines whether it should call itself or not. If a recursive function do not have an end condition, it will infinitely call itself, and inevitably an error shall occur. The error in this case is usually a stack overflow. Let's take a look at an example code. Here is a function for factorial. As you can see, we have a parameter n, and inside we immediately see an if statement, which indicates we are having a branching. So we are having a possibility of an end condition, which in this case is if n is less than or equal to 1, it returns 1. So when a function returns a static value or a literal value, that is the end of the function. Otherwise, it is going to return n times factorial n minus 1. So as you can see here, this is a recursive call, the factorial n minus 1. So we are calling the same method or the same function, but this time the parameter is less than 1 or is 1 less. So if you take a look at here, the if n is less than or equal to 1, return 1. This is the end condition. And this part here, factorial n minus 1, this is the recursive call. So if we are going to execute the factorial function with, in this case, for this example, we have a parameter of 3. Of course, this is going to execute that function. And in that function execution, the value of n here is going to be 3. Since 3 is not less than or equal to 1, this is the if statement is not going to be executed. Instead, it will be executing the else statement, which says here it is going to return the value of n multiplied by factorial n minus 1. Since this is a call to a function, that same function, it is first going to be executed. So it is going to have another version of the factorial call, but this time the value of n is n minus 1. So in this second call, the n is 2. Since 2 is still not less than or equal to 1, it is going to execute still the else statement, which will again call a return with n multiplied by factorial n. So another version of the method or function is called, but this time the value is of n is 1. Since 1 is less than or equal to 1, it is going to return 1 as stated in the if statement. Now, this will return 1, and that 1 value is what is being received by that statement in the second call, n times factorial n minus 1. So that is equivalent to n times 1. And that n times 1 is what is being returned. So, since the n is 2, it is going to return 2 times 1, which is 2. And now in the first call, it will return 2 in that statement. And since in that function call, the n is 3, this is equivalent to n times the value that is returned by the factorial call, which is 2. So it will return 3 times 2, which is 6. Alright? So that is how recursion works. Recursion can also be taken as an iterative statement. Because of the nature of recursion, of repeatedly calling itself until the state in which the end condition is met, you can also look at recursion as an iterative statement. In fact, you can solve some iterative problems using recursion. However, you need to bear in mind that recursion can have greater processing overhead than simple iterative solutions. At this point, we are going to take a look at a coding demonstration. So here we are once again in our Visual Studio Code editor. First of all, we're going to create a new file, and we'll call this recursion demo.java. And inside of here, we're going to create a function, a static function, which returns an int and say factorial int n. Again, we're going to write the code here. If n is less than or equal to 1, we're going to return 1. Else, we're going to return n times the factorial, the recursive call here, n minus 1. Alright? And let's have a main method which we are going to use to invoke this factorial call. So here, we're going to ask for an input. Let's first import our scanner. And we'll ask our user to input a value, an integer value. Enter an integer. This will be for our n. And of course, let's see that next thing. And we'll just call, we'll just assign our output as our fact is equal to the call to the function factorial of n. And let us display the output. The factorial of n is fact. Alright? And running this program, we have a problem here. Okay, we missed one of that blast. Right, let's first clear this out and run. Alright, enter an integer. If we put 3, the factorial of 3 is 6. Just like in the demonstration, in the graphic demonstration earlier. Let's run this again, and let's type 4, and the factorial of 4 is 24. Now, talking about the end condition, what if we are going to have a recursive call without an end condition? Let's try one. Public static void, and let's just do test. And here we have n again, but instead of having an if statement, we just simply are going to display the value of n, and then call again test n plus 1. So this is the recursive call, but we don't have any end condition. And so in our main method, let's change this. Let me just comment this out, and instead we're going to be calling test of n. So what will happen? Let's first clear our terminal and run the program. So here we are being asked to enter an integer. Let's say we enter 1 and press enter, and it displays so many numbers until finally we have an error. The reason for this is it keeps on calling and calling without end, and until such time that the stack, it is a memory allocation in Java that is being used every time you call a function, and there is a limitation to that. And since our factorial, or not factorial, our test function calls itself infinitely, it reaches to the point wherein the area for a function call to be stored is filled up, and that is when that stack overflow will happen, that error. So always make sure that you have an end condition in your factorial, in your recursive functions. And also, even if you do have an end condition, you have to make sure that that end condition will be achieved, because otherwise if you do have an end condition but that end condition does not happen. For example, if we change our factorial here, instead of having n less than or equal to 1, instead we just say if n is greater than or equal to 1, in that case, and we start with a value that, say for example, instead let's just say n is greater than or equal to 10, and we started with a 5, and since 5 becomes 4 and 4 becomes 3, it will never happen that n will be greater than or equal to 10, and this will never be called. So although you have a statement that might look like an end condition, sometimes this end condition will never happen, and so it will keep on executing until an error will happen. Okay? So since recursion is a little bit daunting to understand for the first time, I will also be putting in some links for other videos that talks about recursion. So that is it for this video. Thank you so much for watching, and see you again in the next one.